Hello. So today we're going to be talking about parallel wires. And so this is going to be related to electromagnetism. We're going to see a little bit of this in unit 5.4. And this can be a little bit of a difficult concept to understand. So we're going to go through it today. So let's say we have two wires with a current going through them. And so in situation one, let's say that both of these both of these wires have currents going in the same direction. And let's say these currents are going in that direction that we've labeled with the arrow. So let's look at wire one, and we'll come to wire two later. Let's look at what happens with wire one. We know that the current is going upwards, and so we can use the right hand grip rule to see where the magnetic field that this current is generating, what the direction of that magnetic field is. So using the right hand grip rule, we can point the current towards that upwards direction. And so we'll see on this side, or on the right hand side, there's a bunch of magnetic field lines going through the paper. And on the other side, we're going to see that it's coming towards us. So we're going to have a bunch of magnetic field lines coming towards us. And so on the right-hand side of this wire, those field lines are going to be going into the paper, and we have to remember that this field is going to be going a long way. We like to say to infinity. So we're going to have that same magnetic field over here as well. And so now let's look at the effect that this has on wire 2. We know the motor effect, and so what force is it going to experience? Let's see. Now we can use the right hand slap rule or Fleming's left hand rule. We know the direction of the current, and we know the direction of the magnetic field. We know that it's going into the paper. Our magnetic field is going into the paper, or maybe into the screen. So that's going to tell us that actually our force is towards the left-hand side. The left-hand side. And so we know our wire is going to be feeling a force in that direction. But we also need to remember there's a current going through wire 2 as well, and that's going to generate its own magnetic field. So let's look at that over here as well. We have our wire 2, its current is going up, and so on the right-hand side of wire 2, we're going to be getting some more magnetic fields going into the paper. And on the left-hand side, we're going to be getting magnetic fields coming towards us. So let's put this in here as well. Oh, I'm accidentally drawing little negative signs in there. And so beyond wire 1, that magnetic field is still going to be there. So let's draw some more of those field lines coming towards us, either from the screen or from the paper. And so let's again use the right hand rule, or the right hand slap rule, or Fleming's left hand rule. We know that our current is going upwards, and our magnetic field is going towards us. And our magnetic field is going to be going towards us. And so this is actually going to result in a force in this direction. And so what this is basically telling us is that when we have parallel wires carrying identical currents, they're going to have an attractive force between them. Let's write this down. So parallel wires with identical currents, and we're talking direction here, have an attractive force between them. So let's look at situation number 2 now. Let's say we have two parallel wires again, obviously. And so let's say the direction of one of these wires is up, but the direction, or I shouldn't be saying direction, the current of the other wire is going down. Let's make this a little bit more clear. This current is going up, this current is going down in opposite directions. How is this going to affect the forces between the two parallel wires? So let's look at the first wire. Again, let's use our right hand grip rule. We're going to know that on this side, our magnetic field is going to be going into the screener paper, and on this side, it's going to be coming out. So now let's look at the effect that this has on wire number 2. When we use our right hand slap rule or left hand, or Fleming's left hand rule, we're actually going to see, wait, let me extend this magnetic field a little bit further. We're actually going to see that this is going to cause a force in the right direction. So this wire is actually going to feel a force that way. Now, again, current or wire number 2 is going to be creating its own magnetic field due to its current. And so how's that going to look? It's going, we can use our right hand grip rule. We're going to see that on this side, we have our magnetic field going into the paper. And on this side, it's coming out. And we're going to see that this magnetic field extends as well. And so when we look at the effect that this has on wire number 1, again, right hand slap rule, left hand Fleming's rule, you need to be really familiar in which context we use these. We're actually going to see that the wire is going to experience a force to the left. And so this is going to tell us another thing about parallel wires. So parallel wires with opposite currents will repel against each other. So this is what we need to know about parallel wires. Hope this explanation helps.